Hello there, playing with junk again. This time Sun Microsystems blade enclosure 6000 with some blade servers inside. We have here three T6320 blades. It's written here. 3 times the same blade. Although this one is a little bit newer, it already has the Oracle label. You can fit up to 10 blade servers inside this cabinet here. Here we have 2 power supplies. In fact, there are 4 power supplies. It's 2 double power supplies. And then on the back side we have 4 mains inputs, 2 inputs for each power supply. We have 6 big fans here. We have Ethernet connections to all the blades, and then we have fiber channel cards only for the first blade here. This system was not fully populated. Well, and before I take it apart, I will turn it on. So please set your volume a little bit down if you're listening with headphones. It could be a little bit loud. One, 2, 3, 4. After a while it slows down the fans a little bit because the management module is starting. It is started now. You can see the solid green light. So this now is the normal operating noise of this system. Yeah, I can't turn any blade servers on because they are not ready yet. But I think you get an idea how this works. So I will turn it off again. So that's better. So you can hear me and I can hear myself. It's not always so easy. Now it's quiet. Takes a while. So now it's powered off and let's take a look what's inside. As I said before, we have here power supplies. Ooh, heavy. It's 2 power supplies in one box. It has here fans. they can be exchanged from the outside, just in case if one of the three is failing. And that's the power supply here. Fan box, big massive DC connectors here. AC input is one here and the other one here. That looks like silver. It's very black now. And some control connections here. And of course we have the same unit again. Let's see, where are the technical data? It's about here. 2 inputs, 5600 watt maximum. That's for one double power supply. 12 volt, 240 amps, 2 times. 3.3 volt, 12 amps, okay. So that makes 12.3 volt and 480 amps. Okay, that's the reason for the big connectors here. And they're not black because they have burned or something like that. It's just corrosion. As you know, silver contacts can get black, as well as silver cutlery gets black after a while and has to be polished. Take a look at the blade servos here. There are 3 identical servos. That's a T6320 servo, as you can see here. The T stands for Spark processors, so they don't have any Intel processors, and I need another tool here. This server here only has one processor, although it has multiple cores. And you see solid copper, that's worth $1 or $2. That's the Spark processor here. And we have, of course, space for some memories. What memories do we have? PC2 5300F. F as fully buffered. I will take them out. There are 8 gigabytes. Okay, that's pretty big for a machine of this age. So we have 64 gigabytes here. Then we have here a RAM and a FEM. RAM means RAID expansion module. You simply move that lever. That lifts out the connector here. That goes to this connector on the board. And that's just a little RAID card that makes it possible to connect the 4 drives here. That's only blank fillers here. You can have up to 4 drives, 2.5-inch drives, hot swap, and you can connect them in RAID 0 or 1, and I think together with the RAID card here maybe RAID 5. So the 2 drives, SAS serial SCSI drives, have 2 SAS wires. Go down back here. Let me see under that lid here. Yeah, they just go directly to the board. Okay, same on this side. 2 drives, 2 cables, 4 drives, 4 cables. That's the power supply for the drives. A short cable from the board to the drive backplane. There are the 2 connectors for the drive. Then we have another card here. There is a tap and a big connector. There is a little bit more on this card. That's the how do they call it? The server management card, or ILOM, as some called it a little bit earlier. It's a remote server management everything card. It has its own processor. It runs as soon as the blade has some power. It runs independently. It has its own backup battery for some data. It has its own Ethernet connections. I think it even has its own graphics on it. I'm not sure if this is the case. There's some flash RAM and dynamic RAM for the processor, firmware, everything. So if you connect to the blade, you first connect to that card, and that allows you to bring the blade online, to power it up and all that stuff. It checks the temperatures inside. Okay, what do we have? ATI ES1000 graphics chip. You may wonder where the graphics is going. We have here a special interface. This is a cable is connected here with a VGA graphics connector and 2 USB connectors. So with this breakout cable here, you can connect a monitor, keyboard and a mouse, and you can use this thing like a normal rack server or a standalone server. DC converter for the CPU. More DC converters for the RAM. They need different voltages. They need different powers. More DC converters, because the power supplies only supply 12 volt and everything else is converted inside the blade. There's another one. There's another one. So most stuff on this board, there's another one, are DC converters and a little bit of graphics, a little bit of Ethernet. I don't know what these NEC chips are doing. Maybe we can find it out. There is a number. Certainly some people will look in the internet. Then we have a supercapacitor here. I don't know if they do the same as IBM does. For example, IBM has a supercapacitor. Yes, that's it. There is a button. The problem is if you have, for example, a failed memory here and you don't know which one has failed, there are LEDs. For each socket here is an LED, an error LED. But the problem is, as long as the server is inside the cabinet, you cannot see the LED. So what do? You take it out, you open the cover, you push that button, and the supercap here is providing power to light up the LED, and you can see where the problem actually is. You don't have a big display or LED display or whatever on the front, but they use this technology, IBM does the same for all the parts that are not reachable from the outside or visible from the outside. You have a button, you can take the module out, push the button, and the LEDs will tell you what's wrong. Okay, what else? Not much. Okay, I think that's it about the blade. So that's the connections inside the chassis. We have 10 connectors for 10 blade servers. All the connections you normally have on a rack mount server, in this case they go to one multi-pin connector like this here. And then they go further to the backplane. So this is called a midplane because it's sandwiched between the servers and the modules on the back. The thick cables here are, I think, oh yes, that's the power cables. They come from the right side there where the power connections are. They go up to the power supplies that are behind this cover here. You see the two power, the two 230 volt AC connectors, and below the low voltage connectors, and also the control signal connector in the center. Here you have some louvers, some jalousies that cover the fans, and that has a purpose. All the fans here are hot pluggable, so you can remove them while the system is working. They are redundant. It's two fans bolted together. Nice big one, strong one. And if you take out one fan and there is only a big hole, all the air would be sucked in here instead of pushed out on the other side. So these jalousies here close automatically, and they only open if there is enough suction from the fan in this direction here. Okay. We have 6 double fan units, makes 12 fans in total. There's a screw. I have to get the screwdriver. Seems to be a long screw. So come on. Now it's gone. Okay, what we have here are 2 connectors for the fans going through that small board here to another connector that goes there, and I think that's the back side of the midplane. Yes, here are the wires from the AC input. There is another service door right here next to the power inputs. Let's see what's behind. Oh no, really? Okay, I have to show you that. That's not nice. It says, caution, hazardous voltage. And then you see this. And in fact, I don't really like it because they used only this half insulated connectors here. They are also fully insulated with the insulation up the full way here. The problem I have, it's certainly technically correct. I think that's about 5, maybe 6 millimeters here, but there is absolutely no insulation between this bare metal 230 volt connector and the chassis frame here. Absolutely nothing. And even on the cover there is no insulation, no plastic foil or mylar tape or anything, and I think that's not too good. Especially if I compare that with the old Sun machines. They looked much better on this regard. It's a little bit cheap. It's probably technically okay, but I don't like it. Really, that's not the way how to do it in a expensive piece of equipment like that. Let's have a look on the back side. We have here 20 slots, 2 for each blade server. The first 2 are populated, the other 18 are just empty fillers like that. We have here 2 fiber channel cards with 2 ports each. 1, 2 and 4 means 1, 2 and 4 gigabit per second, so the maximum speed for this is 4 gigabit. Not the newest ones, we are at the moment at I think 16 gigabits. And that's the inside. It looks a bit like a PCI Express connector, but it could also be something totally proprietary, but I think it's PCI Express. You also see the lines here. 1, 2, 3, 4, 5, 6, 7, 8 times 8 PCI Express could be, yes, okay. We have a QLogic chip. We have some, I don't know, is it RAM or something? Probably on the back side. I think that's a relatively normal standard fiber channel card, PCI Express, but in a special shape, in a special form factor to fit into that machine here. 2 times. That's the slots for these I/O cards. Probably PCI Express. Probably something Sun special, but certainly not much better than PCI Express. Okay, Ethernet ports. How do they work? The Ethernet card is a little bit disappointing. It has 1, 2, 3, 4, 5, 10 Ethernet connectors, 1 for each blade. Then we have a second card, makes 2 Ethernet connections per blade. And there is absolutely nothing on the board except the connectors here that go to the backplane and the connectors here that go to the outside world, and there is nothing. Well, there are a couple of capacitors. There's a chip, maybe to identify this module so that the management board knows what kind of module is installed. You probably can have an Ethernet switch module here. there's a fuse. Don't know exactly what for. Maybe if this chip burns out, you need that fuse. Okay, it's always good to have a fuse, but that's really not much on it. I think the power supply should be a little bit more interesting. I just have no idea how to open that up. I think that could be the right direction. Okay, that was quite a lot of screws. Have you counted them? I didn't, but I would say 20 or something only for that cover. Here we have insulation. Okay, we don't have the large clearances between the cover and the board, but okay, that looks better to my eye. Okay, we have black silver coated, maybe it's silver coated copper, maybe it's pure silver, you never know. That stuff is expensive anyway, so let's see if we can get that board out. I don't know if that's so easy or if we need help of the soldering iron. Five and a half kilowatts. Okay, it seems there is a connector soldered here directly to a board. No, it is a connector. Okay, we have more screws. More screws. And a screw underneath the label, I'm pretty sure. Yes, at least one here. Okay. Moves, and another screw. Okay. Good insulation. As I said before, we have two independent power supplies inside the box. Everything is symmetrical. There's the connectors for the fans. Oops, I destroy my camera. That's a funny connector here. They soldered a piece of wire to that PCB to get a sharper point of contact with these springs. You see the mark here goes to that piece of wire, maybe silver wire, maybe just some kind of wire. Input fuse, first stage switching, what are they doing? Where are the transformers? Is that everything? 4 small transformers like that, must be quite a high frequency. That looks like rectifiers and filtering. Some capacitors, not too much. How big are they? 4,700 microfarad. Rubicon, yes, the good ones. 16 volt. We have an output of 12 volts, so there is not much ripple to filter out. Okay, it seems the switching frequency is relatively high, and that's so you don't need too much filtering capacitors. There are all this blackened here, silver stuff. Goes here, goes here. Is that positive or negative? Can't say that. And there's the other side, positive, negative. Don't know which one is which. Okay, and of course we have that board. Yeah, that, of course that's the main input here, with some serious filtering, fuse, capacitors, chokes, over voltage protections, rectifier, standard 4-pin rectifier as we know it, a little bit more filtering, filter caps for DC, some connectors that went in that direction. I'm wondering, we don't have any. Oh yes, okay, there's the first switcher to compensate for 110 or 230 volt input, to give this always the same charge of, I would say, about 400 volts or 350 or something. No matter what input you have, what input voltage, everything is regulated automatically. There are two controller boards here with a lot of chips. Okay, some transformer, maybe for standby voltages. And oh yeah, of course, that's the DC, high voltage DC bus that comes from here, from the capacitors, goes down this threaded rods here to the other board. That's just some standoffs insulation. Here we have, is it something? Yes. It's written like, oh, it's the 3.3 volt ground. You can read it down here. And that's 3.3 volt internal interrupt, I don't know. Okay, that's also a power connection here. Okay, I think that's about it. And this unit now goes to scrap because we already have a couple of them. And I saw it on eBay today. You can have such a sun blade enclosure with all the servers, with everything on the backside for $200. So I think it's not even worth to put it on a pallet and ship it somewhere. So the only pallet where I put it on is the one that goes to the recycling plant, where it will be shredded and disassembled, and maybe next year or a little bit later a new server will be made from all that stuff here. Wow. Thanks for watching.